Today we are working on lesson 7.7, solving inequalities using multiplication or division. This is on page 338. Our purpose today is to use multiplication or division to solve an inequality and be able to apply it to real-world situations. We are going to be using the exact same strategies we did when we were solving equations and solving equations using, inequalities using multiplication and division. So remember, since we're talking about inequalities, it could include greater than, less than, greater than or equal to, or less than or equal to. And we are going to be using inverse operations to isolate the variable or to get the variable by itself. Okay, first let's talk about the multiplication property of inequality. When you multiply each side of an inequality by the same positive number, the inequality remains true. Now, one important thing to remember here today is we are talking about only positive numbers. Eventually, we will talk about negatives in another chapter. So when we multiply by the same positive number on both sides of an inequality, the inequality remains true. For example, in the inequality, 8 is greater than 6. When I multiply each side by 2, my new inequality is 16 is greater than 12. So it stays the same as far as whether it's true or not, regardless of what number you use, as long as you multiply the same thing on the left and the right, and it's a positive number. Okay, let's take a look at how this applies to algebra. Our second example, we have x divided by 4 is going to be less than 2. So I'm going to multiply each side by 4, and remember, the multiplication and division will essentially cancel each other out. And now I have x is less than 8. Now, before you can actually graph an inequality, we need to get the variable by itself. Let's take a look at some examples of the division property of inequality. All of the same rules still apply. When you divide each side of an inequality by the same positive number, and remember, the key here, once again, is positive, the inequality remains true. So, in my first example, 8 is greater than 6. If I divide each side by 2, my new inequality is 4 is greater than 3. And of course, you know this is still true. Looking at the algebra example over on the other side, we have 4x is less than 8. So in order to get the variable, or the x by itself, I need to cancel out that multiplying x by 4. And we do that by dividing it. So the 4's cancel out because 4 divided by 4 leaves us with 1x. And we all know that 1 of a variable is the same as just having the variable, or the x by itself. So, and then we take the other side, divide it by 4. And my new inequality is x is less than 2. Now I want to once again point out that these two inequalities are equal to each other because we are doing the same thing to both sides of the inequality. All of these rules for both multiplication and division are true if we are using less than or equal to and greater than or equal to as well.